President Kim, President Dixon, Director Lee, Professor Cho, Director Kong, and all dear guests. It's my great pleasure and honor to be in this conference, and to share my works in Stage Machine Lab with you. Let me start with briefing about myself in academic background and in professional experience later. I graduated from the best university in Taiwan, the National Taiwan University, or NTU for short. I obtained the BS as well as the MS degree from Electrical Engineering Department, where many key persons of TSMC came from. I served Taiwan as a second lieutenant for 2 years, and later I determined to turn to theater world. After the obligatory service, I entered into the MA program of drama in NTU. Later, I was awarded with the government scholarship and went abroad to Yale School of Drama. While pursuing the MFA degree with graduation honor, I learned how to solve the technical challenges. I have been teaching 21 years in Taipei National University of the Arts, or TNUA for short. In my department, Theatrical Design and Technology, there are 4 majors. And they are Scenic Design, Costume Design, Lighting Design, and Technical Design. I was awarded as the Distinguished Professor in 2013, which was 6 years after I established my Stage Machine Lab. I extended the influence of my lab further by co-founding the company called Cubicle Motivation System, or CMS for short. In addition to my teaching in TNUA and my collaborating with CMS, I was assigned as the Director of Industry Academia Cooperation Section, Research and Development Office in TNUA. My first example to share was a project for an advanced course in technical design. In theatrical department, all design processes have to mix the hands-on experience with design works. The topics of the projects were determined not by myself, but also by my students, who would raise their choices according to their interest or enthusiasm about anything. As their instructor, I would advise and pick whatever could be the most appropriate for their learning curve. In 2013, the students made a wish to build a mechanical surfboard, which might be used on stage. The famous movie directed by An Lee, Life of Pi, immediately came into my mind, where the Bengal tiger spent its last part of life with the protagonist Pi on a boat, which was animated by mechanism called Stewart Platform. Stewart Platform is a beautiful mechanical structure with 6 degrees of freedom, which are controlled by 6 individual linear actuators. Besides, the application could be used in Life of Pi or flight simulators. I didn't know anything about Stewart Platform or how it works, but learning by doing is always the best golden rule. The more practical and the deeper I worked on it, the more exquisite I found about Stewart Platform. 4 technical design students and I worked together to design and discuss how to make it work. As soon as we had the whole plan, we found we couldn't afford it in our course. So we came up with the idea of raising funds through internet platform, Flying V, and did get enough funds for our project. Through the project, we learned a lot about mechanical parts, positioning control, etc. And I also refreshed some of my programming skills such as Visual Basic. The surfboard project did open a new window for my Stage Machine Lab. Year 2013 was kind of an important year for me, in addition to the surfboard. I began to attend stage automation for rock concerts in Taiwan. My new Stewart Platform work in TNUA aroused quite a sensation in Taiwan. I was interviewed by newspaper, magazine, even the TV program. In the YouTube channel I run, many people asked me if they can, or where to, buy or rent such a surfboard on Earth. It's a mission impossible for me because I don't have a company, and, most of importance, the work in 2013 is just a mock-up without the possibility to be toured, due to its poor mobility. 8 years later, a local government officer asked me if I could send my automated surfboard to Taidong, where an international surfing game was to hold in 3 months. At that period, I had been using Arduino to teach technical design students as a tool to learn programming and automation for 5 years. The long history inquiries for surfboard to buy or rent became a thrust pushing me to renovate the surfboard machines. The goals are to make it portable, easy to use and maintain, and controllable by theatrical lighting console. With experience of 8 more years, and the funding from CMS, I designed and built this new version in time for the international game, where it was displayed and provided publicly for free rides. The most special feature of the new surfboard was that the automation was triggered by lighting console, where I used the simulating lighting console software in a laptop to set up the cues for the ride sequences by 5 different levels from easy to difficult. And there were more than 300 people joining that free ride funds with quite thrilling experience. The courage to open it to the public meant my confidence about the updated surfboard. I was so satisfied by the result, but the story didn't end yet. 1 year later, the CMS even sold one more set ordered by a company whose business was equipment testing, and whose capital assets was more than $16 million, and whose number of employees was more than 250. In my lab and related courses, I often use a lot of toys or simple hardware to simulate the stage machine. For example, I love a building block toy called Kinex, which could create a lot of simulation for mechanical motions. The 6-axis Stewart platform mechanism has some issue of height when used in a large-scale application. After my research, I found the 3 axes of crank mechanism with universal joints would do the job with lesser height. I designed this monster, which could carry an SUV while spinning and tilting it in 3 dimensions. From toy to practical work, the Kinex gives me a lot of fun and bears a lot of potential for evaluating any new ideas. Believe it or not, my accidental encounter with it came from a birthday gift I bought for my best friend's son. I never thought about using it as a tool until one day my friend told me that his son played with it for many years and never got bored. For more than 10 years, I have been invited by Wu Zhen Festival as the technical consultant for international companies. In 2016, I flied over to Wu Zhen for the site visiting with the technical team from German company. I traveled with my wife Jessie and happened to visit the local museum, witnessing the beautiful creative work by Korean artist Cho Yu Ram. It's a delicately and sensationally built and a lot of fun to watch. Then I turned to my wife and said, "I can do this too. But I am not an artist, I am a technical designer of the theater. So there's no director or designer ever asking me to do that." By then, 2016, I haven't used any 3D printing technique or operated any laser cut machine on my own. Our department happened to purchase some 3D printer and laser cut machine in that summer. I have been a 3D CAD fanatic since I learned AutoCAD at Yale in 1998. After I came back from Wu Zhen, I quickly designed a simple, bionic machine, inspired by Cho Yu Ram's work, and created this piece of work in 2 weeks just by our printer and laser cut machine, with some servo motors, which has a sinusoidal motion on its spines, and a regularly jerky motion at random moment by coding. I also applied some simple LED lighting effects on this unnamed bionic work who would respond to the dB value of the mic sensor with the change of lights into different extent of scary white. Thus, I kind of fell in love with this creative process, although I still had no time for it regarding my teaching jobs. I want to show some works from the students I was teaching after I upgraded myself with Arduino. This is the first time I put the mechanical design and programming together to teach technical major students of the junior year. Although it was kind of a teaching experiment, the results are quite exciting. As you can see in the video, these works represent a lot of potentials from idea to realization. I always say, no matter it is about learning or working, the motivation matters. In these final projects of a semester, for the very first time in their lives, the students touched the motor, wired the circuits, designed the mechanism, and wrote the Arduino programs. Many of them did excellent jobs, and even surprised themselves and their parents. In my lecture, I often introduced this special student to my audience. Miss Ru Ho Xiao obtained her bachelor degree in German Language and Culture Department. With such a background but with strong motivation for learning, she entered my graduate program and majored in technical design under my guidance. During her 2 years study, she had done 3 different amazing works with bionic projects, surprising those who knew her background. In fact, she might become the 9th student that I had taught and recommended who got the admission into Yale School of Drama, where I graduated from as well. In her work titled as Robotic Arm, using the sensor of a simple flex resistor created a new approach for my lab. Bionic projects often appear in my lab works. In 2021, besides the new surfboard, I also worked on an interesting project about mechanical bird. A junior high school president in a rural county asked me for helping them to design and build an animated waterfowl. Before that, I had done a lot of projects using linkage mechanism, but I don't know how to do it properly. I seek inspiration by Googling such a topic, and the best solution might be Ichikawa's idea. Unfortunately, the information that I could found was only some simple illustration without much detail. And there seemed to be no one ever realizing his idea in life, which was to use just one motor to drive both the inner and the outer wings at the same time. I utilized AutoCAD's parametrical design and simulation to revise the geometric proportion of the bird's wings several times. Meanwhile, I add some creative idea that the bird's body could also have an up and down motion by the same motor. The result was quite amazing and it became the opening ceremony of the junior high school's art festival. Later, they even held an activity for some families, parents and young children, for experiencing the assembly of the birds. Another bionic project was the toy bear for a commercial theater production in 2017. In this play, the toy bear was a gift from the father to his daughter. The director's request was quite simple, that the bear had to move his head or arms for simple responses. This project involved simple mechanical design, big servos, and a remote control through PS2. I divided the motions into certain groups of commands as the combinations for director's choice. The toy bear looked like a regular one until the last moment of the play. The father passed away and became an angel to guard his daughter. One day, when the daughter missed the father and talked to the bear, and the bear suddenly moved and responded to the daughter's words. Another class example I want to mention today was a personal project. One of the students in the TD group came to me and asked for doing a project like study bed. We took about 30 minutes to discuss how it worked, and, due to the limited storage space, turned that into a project called study sofa. One semester later, we run into a production requiring a similar mechanism. At first sight, they looked very different. However, these two projects applied exactly the same principle, which I call parallelism. Again, it turned out to be a successful project in terms of final results and learning effects. This is how I enjoy my career. The projects for the lab or the courses could extend into the professional fields, as long as the experiments are thorough, informative, instructive, and inspiring. And here is what I told the students often. Don't ignore any experience you've learned from any experiment, which might become the critical solution for your next project. The next example was also relative to the linkage mechanism. The origami and paper cutting are the visual tones of the dancing work, which is called My Dear Ho's dance company MeImage produced it in 2013 and entered into the final contest of 5 best works in Tai Shin Art Prize, which has been the most eminent art competition in Taiwan. I dare not to answer Ho's request for cooperation because, first, the folding of non-rectangular shapes was quite difficult, in terms of the positioning control, as well as to support dancer's body on a floating stage. Second, I was not competent enough at that time to deal with the material, mechanism, and the motion control simultaneously. In spite of its achievement, Professor Ho's wish for folding the stage had never realized until this year, 2023. At the end of last year, as the dean of the dance school in TNUA, Ho was invited to revive My Dear for Taipei Arts Festival. And she came to me for the folding stage again. I guessed I had more courage than ever, so we began to work on the possibility. During the design period, our proposal to the Culture Ministry for funding was rejected, but we didn't quit. Without enough funding, especially from the government, I came up with some weird idea. For motion of stage deck like this, with non-uniform travel distances among all the linear actuators, the designers often incline towards using servo or encoder feedback system to have precise motion control. But it is certainly very expensive, and meanwhile, it would be very difficult to predict the distance command for each individual axis without destroying the decks by mistakes. My weird idea could relatively simple and much cheaper. By using the hydraulic system and applying the Pascal's principle, which means a pressure change at any point in a confined and incompressible fluid would be fully transmitted throughout the fluid. The principle could explain how the lifting fluid jack works, and could apply in countless industries. With the Pascal's principle, use the hydraulic cylinders to drive the deck. And make sure all the cylinders on the same ridge line share one confined tubing. When the cylinders with the same tubing drive the ridge line, the pressure would be transmitted to support the deck. But the travel distance of the cylinders would be restricted by the rigidity of the irregular decks. As long as the decks and the hinges between them are strong enough, the origami goal would be achieved. If we have time, I would like to share with you this clip of the performance. At the beginning of 2022, CMS and I started a new project, VOM, which was to build 3 sets of kinetic sculptures for our upcoming new show, Awakening, in Las Vegas. Awakening, conceived and co-produced by Wynn Resorts, is an original and $120 million production opened in November 2022. It involves magic, fantasy, and a more than 300 axes of automation to do the tricks on stage. I was invited to design and build these kinetic props by the set designer George Sapin. George and I got acquainted because we had joined the project in Xi'an, China. He told me that he had tried to interview some scene shops in US and couldn't find anyone he would entrust. Therefore he called me and see if I would be able to take the job. The goals of the 3 sculptures are quite simple. Each VOM has to wave its 28 wings sequentially to and fro by only one motor. And there are several configurations for the wings to be set and motivated by lighting DMX control protocol. Because the props would be very close to the audience, the finishing has to be clean and pretty. We spent almost 2 months to build the mock-up for examining our design and found a lot of flaws to be corrected. Some issues were very difficult to deal with, so that another 2 months were spent to get the mechanical parts right. After we finally showed a successful mock-up to the client, we got the order with quite a decent price. During the production, the client and CMS often started a video conference on Saturday 7 a.m. for all sorts of meetings. Eventually the 3 sets were completed and shipped abroad to the port of Los Angeles for our installation on site afterwards. Almost all the employees in CMS were my students trained in TNUA's Stage Machine Lab. The job was nearly perfectly done, and it proved the success of the extension from the lab to the commercial world. In 2013, I began my involvement in designing stage machines for rock concerts. In Taiwan, the business of rock concerts was done by a group of companies irrelevant to education of theater arts. The tour for singer Cheer Chen requires 2 huge rings in the air with the diameter of 18 meters for the big ring. The main structure of the big ring would be circular trusses carrying LED panels and computer lights. The weight of the big ring was estimated as 3 tons. And the goal of the winch is to manipulate the big ring and the small ring with different visual compositions. The production company came to me by my friend's recommendation. After some conversations like the following one, they knew they came to the right place. Here was one question. Some people said each ring needs 6 points to rig because it will be safer with more suspension. Here was my reply. They were absolutely wrong. When you use more than 3 points to rig one ring with automated winches, there will be more than one wire loosen, because the geometry rule says 3 non-collinear points determine a plane. Of course, this project involved a lot of engineering calculation, analysis, etc., where I found my engineering background had fully displayed its advantages. With the reference and specification from famous company abroad and my analysis, we placed the order for trusses in Taiwan's manufacture and saved the budget a lot. If we have time, I would like to share with you this clip of the performance. Therefore, I began my adventure in concert touring business. As I said before, we started a new company called CMS, dedicating to the development of automated machinery for rock concert. This was the first project. It had 2 huge transparent doors consisting of 96 10-meter-long pixel LED strips. The doors had to slide across the stage with tracks at the top and the bottom. The LED strips had to be tilted sideways, skewed or transformed, but the length could not be extended. It was the tricky part of this project. The picture shown here was the core of the solution. Since the distances between the tracks at the top and the bottom could not be changed, the only way to elongate the LED strips was the spring, which I hardly use. However, other than spring, there is almost no substitute to fulfill the request of the show. Now, allow me to play the video clips from the tour of Mayday. In addition to regular lifts, we had several 25-meter span curved LED walls to be lifted up and down independently. At certain moments, they needed to be synchronized with other elements of automation. There were many stage machines designed and built in a very short period of time. As you can see on projection, they were quite unusual to theater industry. Each moving element could be as heavy as 2 to 3 tons. However, this kind of scale and weight are like common language in entertainment business. 4 huge LED panel doors, each had a gigantic size of 6 meter wide by 12 meter high. And the total travel distance covered a 75 meter wide space. In this rock concert production, CMS also designed and fabricated the self-lifting delay towers. The delay towers have at least 2 functions. The first is to hang the line array speakers at the rear part of the audience. Because, as you know, the length of the stadium could be as long as 200 meters across. The audience sit far away couldn't have the coherent feelings about visual and audio unless they can hear the sound directly from the delay towers. The second function is a bonus that the crews can shoot the follow spotlight directly from here, with the needs to create wonders for the audience. With the funds coming from deep pocket of the audience, there are always more possibilities to push the development of technology to infinity and beyond. I am so glad to share with you about my stage machine lab and its extension to the industry as the keynote. And I believe it is not the end of the story. For example, I am right now working on my surfboard project, version 3. To command it with the sensor attached to the surfer's palm, so that he can manipulate the surfboard on his own without any programming from the console. And I believe that all of you sitting here are elites from the machine art industry. Please contact me if you're interested or have any comments or suggestions. And I would be more than happy to work with you in the near future. Thank you for your attention and listening.